Let's take a look at this example. Please notice that this problem has given total impedance. We're supposed to realize that this impedance has no angle. So the very first thing which I'm supposed to do is to find the angle, especially if I have chance to get angle because I have given z total and r. I'm supposed to use the formula for power factor. Power factor is equal cosine of angle theta, and this is also equal z total over r. This is the formula for the parallel circuit. So I have to find angle. So that's why I'm going to use just this part of the formula. So in order to find angle, I'm supposed to simply write this is angle theta equals inverse cosine of z total over r. So I have angle theta equals inverse cosine, and I have z total 2.5 kilo ohms over r, which is equal 4 kilo ohms. This is equal negative 51.31 degrees. This is the angle theta which I'm supposed to write next to z total. That's why I can write that z total is equal 2.5 kilo ohms and angle of negative 51.31 degrees. Please notice that I wrote negative sign next to the value of angle. I did this because I'm dealing with the circuit which has capacitor and resistor in its structure. Okay, so anytime you are going to have capacitor and resistors connected in series or in parallel, the angle is going to be always negative. So next we're supposed to find Y total. Okay, this is admittance. So if Y total is equal 1 over Z total, which is equal 1 over 2.5 kilo ohms and angle of negative 51.31 degrees. Again, let me remind you that it's always good to write the formula first. If you are going to keep writing the formulas, you are going to remember them. Okay, so many students make mistake because they write the values right away without formulas. And later on, when midterm or finals are coming, they are lost. They don't know what particular number means. But if you are going to write formula first, you are going to have very good note to review and you are going to pass every single test. So I have Y total is equal 400 microsiemens and angle of 51.31 degrees. Next, we're supposed to find conductance and capacitive susceptance. In order to find these two quantities, we're supposed to convert the total admittance, right, from polar form to rectangular form. And you're supposed to obtain 250.04 microsiemens plus J 312.21 microsiemens, where the real part of my answer is conductance and the imaginary part is my capacitive susceptance. Next, we're supposed to find theta, but we found already theta, x of c. So I have capacitive reactance is equal 1 over BC, which is equal 1 divided by my BC is equal 312.21 microsiemens and angle of 90 degrees. Okay. Please keep in mind that we have J over here, right? This is the rectangular form. I prefer to work with the polar form. That's why instead of J, I wrote 90 degrees. This is equal 3.2 kiloohms and angle of negative 90 degrees. This is my X of C. Next, we're supposed to find the current which goes through the resistor. But please notice that voltage source is not given. But we have given power, true power, and we have given the resistance. Okay, PR is the power at the resistor. In other words, this is true power. So from these two values we can find the current. Formula for power says power is equal IR square times resistance. Okay. So in order to find the current, I suppose to simply solve this formula for current. In order to do so, I suppose to divide both sides of my equation by R, right? And I'm going to obtain IR square equals P over R. I'm doing everything step by step because some students have difficulties with algebra. So this is going to be equal to IR equals square root P over R, which is equal square root P 2.25 watts over R, which is equal 4 kiloohms. This is equal 23.71 milliamps. I assume that we're supposed to find the RMS current because someone is going to ask me why you didn't add 1/2. How come you know that this is RMS or not peak? So I just simply assume that we have to find RMS, okay? But if in your case the problem is going to say that you have to find the peak value, so you're supposed to just add 1/2 over here. But in this case, we assume that we have to find the RMS values, okay? So this is the current IR. Next, I'm supposed to find current IC. In order to do so, I'm going to find first the voltage source, okay? You're supposed to realize that we are dealing with the parallel circuit. In the parallel circuit, voltage source is equal to the voltage across the resistor, and this is going to be also equal to the voltage across the capacitor. Okay, so I'm supposed to say that VR is equal to VC is equal to voltage source, and this is equal IR times resistance, which is equal 23.71 milliamps times resistance, which is equal 4 kiloohms. This is equal 94.84 volts. So this is the voltage across each component. Now we can find current which goes through the capacitor. So if IC is equal VC over X of C, okay? X of C. Now, so we have 94.84 volts divided by x of c, and we found x of c, this is 3.2 kiloohms, and angle of negative 90 degrees is equal 29.63 milliamps and angle of 90 degrees. This is the current which goes through the capacitor. Next, we're supposed to verify if our answers are correct. How we are going to do that? We are going to use, like always, KCL. KCL says, let me remind you, that the sum of two currents, current which goes through the resistor plus current which goes through the capacitor, is going to give me I total. So I have I total is equal IR, which is 23.71 milliamps, plus IC, which is equal 29.63 milliamps and angle of 90 degrees. This is equal 37.94 milliamps and angle of 51.33 degrees. Okay, this is the I total obtained from the addition of current which goes through the resistor and current which goes through the capacitor. Another way to find the total current is by using Ohm's law. I total is equal voltage source over Z total, where voltage source we found is equal 94.84 volts, 94.84 volts divided by Z total, and we found Z total, this is equal 2.5 kiloohms and angle of negative 51.31. So I have 2.5 kiloohms and angle of negative 51.31 degrees. This is equal 37.93 milliamps and angle of 51.31 degrees. Okay, so this is the current obtained from the division of voltage source by Z total. Next, we're supposed to compare these two values, okay? As you can see, they are close enough. So it means that so far our calculations are okay. Next, we're supposed to find power factor. Power factor is equal cosine of angle theta. So I have cosine of the angle which is next to Z total or Y total. So next to Z total we have negative 51.31 degrees. This is equal 0.625 lead, because current in the RC circuit is going to lead the voltage. That's why I'm supposed to write word lead. Next, we're supposed to find capacitance in my parallel circuit. In order to do so, I'm going to use the formula for the capacitive reactance. X of C is equal 1 over 2 pi Fc. I have to solve this formula for C. So C is equal 1 divided by, open parenthesis, 2 pi F X of C, which is equal 1 divided by, open parenthesis, 2 pi times f, which is equal 400 hertz, times x of c, which is equal 3.2 kiloohms. So the capacitance in my parallel circuit is equal 124.34 nanofarads. Okay, so this is the value of the capacitance in the parallel circuit. Next, we're supposed to find the reactive power. QC is equal IC square times x of c. Again, let me remind you, we assume that we are going to deal with the RMS currents and RMS voltages. That's why I don't write over here 1/2. So I have IC is equal 29.63 milliamps. This has to be raised to the second power times x of c, 3.2 kiloohms. This is equal 2.81 volt ampere reactive. So this is the reactive power in my circuit. Next, we're supposed to find the apparent power. S is equal I total raised to the second power times Z total, which is equal, I total is 37.93 milliamps raised to the second power times Z total, which is equal 2.5 kiloohms. This is equal 3.59 volt ampere. And this is the apparent power in my circuit. Next, we're supposed to find the series equivalent circuit. In order to do so, we're supposed to write one more time the value of Z total. Z total is equal 2.5 kiloohms and angle of negative 51.31 degrees. Next, you're supposed to convert the polar form to rectangular form. And you are going to obtain 1.56 kiloohms minus J 1.95 kiloohms, where the real part of my answer is my RS and imaginary part is my X of C S. Next, we're supposed to find the capacitance of the capacitor in my series equivalent circuit. So we have formula for X of C S is equal 1 over 2 pi F CS. You have to solve this formula for CS. So you'll have CS equals 1 divided by 2 pi times F times X of CS, which is equal 1 divided by, open parenthesis, 2 pi times F 400 hertz times X of CS. We found this is equal 1.95 kiloohms. So this is equal 204.04 nanofarads. Next, we can draw the series equivalent circuit to this parallel circuit. So I have voltage source, which is equal 94.84 volts and has frequency equals 400 Hertz. We have resistor RS, which is equal 1.56 kilohms. Okay, this is my RS, 1.56 kilohms. And we have capacitor, which has capacitance C equals 204.04 nanofarads. Please notice that this circuit is going to have exactly the same total impedance like this one, exactly the same total current, exactly the same powers. So we can say that the problem is solved.